So we'll be using some analogies borrowed from mechanical, civil engineering disciplines and whatnot to kind of explain some of the more abstract electrical principles from a different perspective. And when we look at things, abstract things from multiple perspectives, uh, one or more of those perspectives tend to click a little better. So that's the whole idea, and we'll be doing some of that here, and we do a lot of that in the books that I've published. But anyway. Let's take a look at the agenda for the 2 days. So you see at the very top, we're going to jump into the principles and fundamentals of electricity, DC and AC, and we're going to actually look at the differences between the two types of electricity. When we do these programs, we always, any program that I've put together, any seminar that I've put together, it's always with objectives and deliverables in mind. We want to make sure that at the end of the program, not only do you earn your PDHs, but you walk away having learned something that perhaps you weren't knowledgeable of before you attended the seminar. We want to make sure that, for example, in this program, which is where the title is Electrical Engineering Principles and Practices. So after this program is over, when you deal with your electrical engineering counterparts, electricians, you will feel a much greater sense of comfort in holding discussions with them. You will feel much better, better equipped with understanding of jargon, terminology, and so forth that electricians and electrical engineers use. You'll feel a little more comfortable when they throw some code references at you. You'll feel certainly a lot more comfortable when you look at some of those electrical drawings that they might, spread out in front of you 2 o'clock in the morning in a triage situation trying to troubleshoot something where, without familiarity with those drawings, those symbols might not mean much to you, and not to mention, of course, the value of the knowledge that those drawings project. So we'll be covering 3 different types of drawings, and that's an important deliverable. We'll also show some calculations. We'll show you how to calculate current that's being pulled by certain types of loads like motors, how to, and when those currents are not the full load currents, when you need the actual current versus a full load current, which might be available through tables and so forth. So there are a lot of deliverables like that. One of those deliverables is also being absolutely crystal clear about the difference between AC and DC, and appreciate how AC, single phase AC is inordinately more complex than DC. And then as you go beyond single phase AC, how 3-phase is inordinately more complex than single phase AC. And then what we don't get into, but we do leave you with a flavor of, is the immense complexity of when 3-phase systems are unsymmetrical. And that is, we don't really get deep into it, but we'll just make a mention of it. And so anyway, those are other very important deliverables out of the program. So and the fundamentals are the key to understanding the abstracts, more advanced abstract concepts in electrical engineering, and it is the lack of understanding of fundamentals or lack of clarity related to the fundamentals is something that leads us to building that phobia about electrical engineering or electrical principles or electrical concepts, and we tend to kind of shun them, when we come across concepts that just don't compute, and then we just leave it up to the EE. So that's another important deliverable. We want to make sure your fundamentals of electrical engineering are absolutely solid, so that any new knowledge you might gain or be exposed to, electrical engineering knowledge, or that you might be exposed to after this seminar, you'll be on solid footings. You'll understand it much better and absorb it much better and be able to utilize it better. So we're trying to build those foundations, and therefore we take our time on fundamentals. You'll see that we'll spend oh my goodness, at least 2, 3, 4 hours on just the fundamentals. So just be aware of that. If we're moving at snail's pace during the beginning of the seminar, not to worry. That's just the way it's meant to be. And then we gradually pick up speed. We'll explore electronic devices, 2 basic type of electronic devices, which are the building blocks, the fundamental building blocks, the elemental blocks of electronics and all the smart devices that we have around us that we take for granted. And those 2 devices are diodes and transistors. So we'll introduce you to them, and we'll show you what the symbols look like, so show you some practical examples of them, and so on. And then we'll get into power factor correction. Put you on hold for just 1 second.
All right, no problem.
Okay, so we'll then get into power factor correction. Power factor is a very important concept in AC. Power factor basically is a way to examine and put metrics on how efficiently we're using AC power. So when you buy that AC power from the grid, it's actually delivered in apparent power form, but how much of it is real power is what we're going to examine, and the closer the real power is to apparent power, the better the efficiency. And so, a very important metric in the use of AC in our facilities, industrial complexes, particularly larger facilities, and really even at home we really don't have a way to check power factor. So and there's not a whole lot we can do even if we could improve the power factor. So it doesn't, in the residential realm, it doesn't really make a big difference, but in the commercial, large industrial realms, it makes a huge difference and a huge cost impact. And we'll explore all that. We'll show you the economics associated with improvement of power factor. We'll show you the non-economic benefits of improvement of power factor, which have to do with sustainability of equipment. So we'll explore all of that in this segment. And this is a topic that eludes a lot of people, including some double E's who really don't practice in this area much. They tend to sometimes get a little obfuscated by power factor type of analysis, but we'll cover that, and I think you'll find that by the end of this program you're going to have a very good understanding of power factor and how to correct it. Mm-hmm. And then things will move even faster as we get into this 4th bullet, which is electrical equipment and instrumentation in industrial applications. And that could be large commercial applications as well. But bottom line, in this segment, we look at a lot of pictures. We dissect electrical equipment safely and virtually, through pictures, and open those doors that we cannot open physically. We walk by some of those nondescript panels, and we don't dare try to open those, touch those switches or open those panels. You would as per NFPA 70, you would have to follow the warning stickers that are there, the arc flash labels that are there, and you would have to, in many cases, if not most, you would have to be wearing proper PPE to even in some cases operate those switches. So we're not going to have to worry about that. We're going to take you behind those doors and show you what some of that common electrical equipment consists of and how it's built. What are the major important components and how they work. So again, you'll at the end of all of that, you'll have a much better sense and appreciation of what's behind those closed doors, and also take away the important safety aspects of and have a little more respect for what's in there, and all the caveats associated with the do's and don'ts and so forth. So we'll cover all of that, and we'll use we'll use an MCC and basically kind of break it apart through pictures. We'll look at all kinds of stuff: motor starters, VFDs, variable frequency drives, soft starts, and so forth, and fusible disconnect switches, all of that. And then it'll be you'll find it interesting that we first look at all this stuff physically, what it looks like and how it works, and then we will be linking all of that and evoking all of that information and the second to last segment, where we start talking about or cover the electrical drawings. We'll then basically remind ourselves that, okay, well, on this branch circuit that we see on the drawing, you remember we talked about the motor starter, you remember we talked about the contacts, remember we talked about the overload device. Well, that's how it's represented symbolically on the drawing. So you'll see that connection made between this fourth bullet and the second last bullet, and I think you'll find that helpful. We'll, after the fourth bullet, we'll get into the little bit of an introduction to National Electric Code. This by no means will, make you an expert in National Electric Code. It's not easy to be an expert in the correct interpretation of a National Electric Code. Most EEs who do this, and are well versed in it, are those electrical engineers who continuously, use the code and practice the interpretation of code constantly and stay abreast of the latest revisions of the codes and so forth. But we will, it's a huge document, but we will try to familiarize you with the different segments of it. So if anybody ever mentions a code, it won't just hit you like, a sledgehammer that, whoa, I don't even want to get near it. It's probably too complex or whatever. And it is indeed complex. There's a lot of legalese in it. There are double negatives and there are exceptions to exceptions, and you name it, and it just leaves you confused. And so while you may not, at the end of the program be capable of practicing the code, you will, in your conversations with people who do practice the code, when they throw codes at you, you'll have a good idea where to find more information on it, how to bone up on those concepts or those parts of the codes and articles. So most importantly, you will not be intimidated by any kind of reference to code. You'll be able to form those linkages and references where you can go in and get more information from the code. We'll also talk about the other code, the arc flash code, otherwise known as NFPA 70E. The new revision of it is coming out in 2018. In fact, it's available now. But we're going to give you some appreciation of what arc flash code is all about. And again, that's very, very important area from electrical safety point of view. So, and we have a 8-hour or 7.5 PDH program that deals with arc flash. So if you want to expand your knowledge in that area, indeed look that up. And we